welcome back to another episode, guys. Now, in the previous episode, we just deployed our token, and we were able to integrate or create the contract manager and then import the token details into a script here that we can reference later on. And today we'll actually be looking at interacting with some of these classes and stuff. Let's go here. There we go. Today we'll be looking at going into some of these read and write functions here. Now, I thought we'll start off pretty simple. We'll get some basic stuff like, you know, the symbol, the total supply, the balance off for our address, and we'll go from there. We'll do some fun reads and see how we can read data from a contract first before we dig into the writes. So yeah, let's get started. Let's not waste any time here. I created this little demo scene that should showcase the connected wallet, the balance of the token, so for the connected wallet, the token name, and the total supply. I've created this little script here, just started it out. Now I know it looks overwhelming, but it's like 90% comments, just so that it's clear. Really, the only thing I've specified is the UI, that at the start, we want the connected wallet text to be our player prefs that we stored back when we connected our wallet. I believe it's episode 3, I think. And just, yeah, invoking a method here. So this method here, the fetch balance, is what we'll be using to actually fetch the amount of strange tokens that we hold as a wallet. We use the balance off method, which you can see is just a string. If we go back here, you'll see the balance off, which is this one here. We're quite literally just grabbing the name of the method. You need to make sure it matches though, like it needs to, like on a grammar level, it has to be the same case and whatnot. So balance off, we're saying that the one argument it takes, the owner, is again just the account player prefs, which should be the connected wallet, and the provider. So there's a reason we actually added the RPC and the manager here. I like to specify mine manually. You don't need to. You can have the SDK do it for you, but it's just more reliable to specify your own RPC endpoint. After which, we create a new contract call. So we're basically saying, hey, this is our contract details. So the contract ABI, the token contract itself, which is all just from the class here. We're just referencing the static strings. And then the provider, which is our RPC. After which, we create a data object, which is our contract call, and we're passing it the owner argument. Now, if you had a read method here that had absolutely no arguments, you would just take that out. You would pass it with absolutely nothing in it, because if you just want to read a number, you want to read a balance or whatever that doesn't require an input, just leave it blank. It's just the best way to go about it. We do a sanity check, debug it, you can never have enough of that, and then we print out the amount we have to our UI text. So let's just jump in and see immediately what that does when we connect. Cool, give it a moment, and sure enough, it works. It shows our connected wallet. It also shows our current balance, which doesn't look pretty at all. So we'll need to fix that. But you can see it's a trillion. If I just raise this up, I believe that's a trillion. I'm not sure. I think it might be. But every token has a decimal. That's the reason you've got this here. So we know we have 18 decimals. So we'll need to divide this big number here by that. In order to do that though, we'll need to import system.numerics so that we can use big integers. So what we'll do is we'll do this one. We can say, let me just think about this one for a moment. We can go big integer, rounded number. Okay, so yeah, okay, we're back. Sorry, I don't know why my editor was being so rough at me. But anyway, so we create a big integer, we can call it anything we need to, and then we just pass our string, which is the data object, into a big integer. Because you can try an integer, but it's going to give you an overflow error because the number we're providing is humongous. It is way too big for an integer. So we use a big integer instead. So we can actually go ahead and we can then try to print that. We'll just go print rounded number, which actually, now that I think of it, won't do much. We won't be doing that. Instead, we'll be going big integer. We'll call it, what can we call this one? final number. I mean, I'm sorry, my naming scheme is absolutely dog at the moment, but hopefully the point comes across. We need to actually round this number off by the amount of decimals we have. So we can do something like, I don't know, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There we go. So that is our decimals. That's how we kind of Mickey Mouse it to make it work. But again, you can do like real math around this. This is just an example to show you how to get your token in here. And then we can go and we can change the text to be the final number. But obviously that needs to be to a string. And I mean, if you really wanted to, you can go nuts and have it be, you know, I don't know, to a 2 decimal stop or whatever you'd call it. So let's go ahead and let's try to run that again now that we know what we know. And if I just, sorry, stop out of this one. And we'll just play that again. We'll actually just have a look and see what happens. Okay, that looks way better. We don't have 40,000 zeros, but we do still have some formatting issues. So let's go back into the canvas. We go back into the scene. This balance can be extended. The total supply can be extended. And the name, well, the name should be fine. I wanna hope it will be fine. But now we know what that is, so we can actually go and we can say to string, and because it's strange, we'll call it str. There we go. So there we go. We've got our symbol and everything sorted, which means if we click on play now, fingers crossed, the formatting should be nice. Which ironically, about 90% of blockchain gaming or blockchain game development is literally formatting stuff to look okay on the other end. Okay, there we go. So that's how many tokens we have. So if I go and I do another method call here, obviously that one won't be nearly as nuts as this one. We'll just copy and paste this one here. We'll be going fetch name. Now, we don't need to pass any arguments of this one, so we can get rid of the arguments entirely. There we go. We don't need any of this stuff. We just need to print. We also don't need any of that stuff. We'll actually just go ahead and we can do token name dot text equals, there we go, that one right there. But obviously we haven't actually made a call, so let's just do name. And I'll just double check. Oh, okay, so it's lowercase. We need to match that case. It's super important. Boom. Name. Everything else stays the same because we've already, you know, input all the details. We've got the contract manager set up, so we're just referencing static strings, which is excellent because the more of these functions you have for different token functions from Remix here or from, you know, the blockchain, the more crazy it's going to become. So let's just make sure we actually invoke this. That's pretty bad casing, man. Let's do that one instead. Alright, cool. Great, so we should be fetching the balance and we should be fetching the name. After we set up the first function, it kind of goes like this because you've set up a boilerplate code and you're just changing a little bit here and a little bit there. Boom, look at that. Look at, there's no modification needed. Strange. This is our strange token. Excellent. Great. And then the last one here is the total supply. Now I know that's kind of boring, but I wanted to cement this into your brains on how we use this. So we can just go, I think it's total supply with a lowercase. Yeah, that is. Okay, excellent. Total supply, we're not passing anything, which means the only thing that changes is that. So let's give it a go and we'll just have a look and see what Unity does with it. Oh, no. Oh, I probably need to call the frickin' method. Okay, now it should work. Confident, now it should work. Let's give it a go. and play. Debug, boom, and of course our total supply, which is like 1 trillion. You could effectively just do the same thing with the supply. You could actually do that. Actually, you know what? I'm not gonna do this to you guys. I'm actually gonna do this properly. Let's do this. We'll go. Actually, we can just keep that as is, and we can just do the same thing. Actually, we'll just copy and paste the whole thing. Alright, now fingers crossed that good old copy paste should do us wonders. We'll just have a look. Dang, look at that. I mean, obviously where we own a wallet, we own the whole supply. Yeah, in the next video, we'll actually look at rights. So in the next video, I'll do transfers, when we transfer a token. When we do a transfer from, perhaps, I'll have a look at that. But effectively in this episode, although lengthy, you've learned how to import your own custom blockchain token into Unity and fetch the balance, the name, and the total supply, which is honestly about 90% more than what you might need to actually create a blockchain game. Now, yeah, let's just keep this going, and we'll see what we can do with the token later on. But congratulations on getting this far, and thank you for sticking with me if you're here. I'll see you guys in the next video.